at the Southeast Research and Extension Center in Parsons. So I actually am closer to Oklahoma than I am to, oh, sorry about that, than I am to my home campus of K-State. I thank the, okay, that's gonna bother me a little bit. So I thank the organizers of the event for inviting me to come, because as I looked on the agenda, I'm the token beef person. So I do thank you guys for inviting me to the crop school. Before I begin, I kind of want to get a little poll of the audience. So for those of you who are about to go to sleep, wake up. How many of you are beef cattle producers? Okay. How many of you are forage crop producers? How many of you are strictly row crop producers? Okay, so now I know if you do fall asleep, it's actually because I'm presenting something dull. You should all be excited and paying attention. Oh, I guess educators. How many educators are in the audience? And others, if you didn't fall in any of those categories. Okay, so my topic today is actually probably a little dull and dry compared to most other things I present, but it becomes really important if you have cattle because we never want to kill our cattle. So I'm actually talking about managing for prussic acid. And when I was prepping for this presentation, I found a 1930 publication. So we've known about prussic acid poisoning actually since the 1900s. So why do we still need to revisit it? If you're like me, you went to sleep and you forgot what you heard the next day. So what is prussic acid? It's also known as hydrocyanic acid poisoning, or essentially cyanide poisoning. Cyanide poisoning in humans is bad. Cyanide poisoning in cattle is bad. What really happens is that the cyanogenic glycosides, specifically durin, is the compound that is found in the epidermal cells of the plants. Now, what causes problems from the cattle perspective is that when they chew or break those cells, that diurin goes through a bunch of different chemical processes, and one of the outcomes of that is cyanide, hydrocarbon cyanide. That cyanide gets absorbed, that's what HCN, gets absorbed into the rumen wall and goes into the bloodstream of the cattle. When it gets into the bloodstream, any oxygen molecules that are on the red blood cells, it kind of traps them on the red blood cells and doesn't let them go to any of the other tissues. So then those cattle suffocate, go through asphyxiation. But before you see that, some of the first clinical symptoms will be rapid breathing, then labored breathing, muscle spasm, get dilated pupils. Then at this point, they get flat out just stupid and mean. If they don't have enough oxygen going to their brain, they lose it. Now, off of these symptoms here, what other health-related events can be seen if your cattle are acting this way? You gotta shout out loud. Nitrates. You see the same beginning clinical signs with nitrates. Anything else? Anaplasmosis. So, I'm bringing this up, and here's my disclaimer. I am not a veterinarian. I am a nutritionist. I spend more time looking at cattle manure than I do looking at diagnosing health-related events. But because their first signs of clinical disease are very similar in the two, of those three different things, Make sure before you apply treatment, you really know what is your issue. Now, luckily, or maybe unluckily, however you depend on it, it makes it easy to diagnose. If your cattle die within 15 minutes of eating something, it was prussic acid. It is a very, very quick acting killer, up to 2 hours. So the good thing is if they survive past 2 hours, they have a good chance of recovering. Another typical sign is the blood is cherry red. What color is the blood of a calf if they have nitrate toxicity? Brown, chocolate brown. So I'm specifically talking about prussic acid, but I am going to go ahead and bring up some nitrate because a lot of the plants that have prussic acid issues also have nitrate issues. So you need to be able to diagnose which one is happening. So in nitrate toxicity, the nitrite from the rumen actually binds to the red blood cells and doesn't allow oxygen on the red blood cells. So then the red blood cells become brown. Whereas in prussic acid, the oxygen gets trapped on the red blood cells, so they're bright red. So that's one way you make sure you can identify them. And if it's anaplasmosis, your blood's white or more cottage cheesy. Also, if you are worried whether it's prussic acid or nitrate toxicity, if it is after 2 hours that your cattle start showing symptoms, it's probably more nitrate issues. Prussic acid is a quick killer. Nitrates take longer to develop. So what are the cutoffs? What is the threshold? When do we start seeing problems? Actually, at 2 milligrams per pound of body weight intake, you can start seeing death. So what do you think, milligrams is probably not something you're typically familiar with. What do you think 2 milligrams looks like in regards to salt? I think it's like a quarter of a teaspoon, half teaspoon, tablespoon, a cup. Yeah, we're down in the half teaspoon, quarter teaspoon range. Doesn't take a lot to cause some issues. And how do you treat it? I kind of hammered on this a few times. You need to know whether you have prussic acid or nitrate toxicity, because treatment for prussic acid is intravenous sodium nitrate. So if you already have a nitrate overload, you don't want to give them more nitrate in the bloodstream. That is a surefire way to make sure you kill your cattle. Also, sodium thiosulfate. And you have to give it before the heart stops. That was my joke to make you laugh a little. If they've already quit having a heartbeat, this intravenous injection is not going to help. Mainly because this nitrate and sulfate, they actually have to get to the red blood cells, all the red blood cells. So the blood has to be pumping through the animal to get to the cells to provide treatment. Make sure diagnosis is correct. We already hammered on that. Mentioned it 3 times. I think that's probably important. Now, another thing, you always read publications about prussic acid and nitrate toxicity. So when I visit with a lot of producers, they say, okay, if I have high nitrates, I automatically have high prussic acid. That's not true. They are 2 independently mechanisms that cause kind of similar clinical signs in cattle and also occur in a lot of similar plant types with a lot of similar environmental effects. So that's why we often think they are the same. But you have several very, very distinct differences. And one of them, I'll go ahead and tell you the punchline now. You can get rid of prussic acid through the process of haying or ensiling. You cut and kill the plant, it'll evaporate and you don't have a problem. On the other hand, if you cut and kill a high nitrate hay, the amount of nitrate in that hay will be there forever and ever, amen. Now, ensiling is one way you could kind of reduce your amount of nitrate, but prussic acid goes away with killing of the plant. Nitrate stays there. Okay, so now I have sufficiently scared you with prussic acid. I've made you want to be a little suicidal even. That prussic acid is bad. Luckily, we have a lot of management practices that can help us minimize our issues for prussic acid. And actually, death due to prussic acid is very low in cattle because you guys already know what to do. I guess I could already just cancel and walk out, you know, because I'm sure you already know what to do. We have more prussic acid death in Johnson grass. Heard a lot more reports of cattle walking across a pasture and get into a patch of Johnson grass. By the time they get to the end of the gate, there's cattle just flopped over dead everywhere. Has anybody else heard that? Those were just the nightmare stories my dad told me. It happens. We have more of an issues with wild Johnson grass than we do of anything else. So, how do you manage for prussic acid? Know what periods will cause high prussic acid and avoid grazing them during those time frames. Identify the plants that have prussic acid potential. Develop your grazing management plan. And actually, if you do want to graze these high prussic acid potential feeds, heavy stalking rates, strip grazing, rotational grazing is what you need to practice. Put 4 to 6 animal units per acre. What is 4 animal units? How many pounds of beef is that? 4,000 pounds of animal per acre. Heavy stocking, short duration. Also, and here's me putting my toe in the fertility world. Put this one in just for Brian. To be able to help manage for prussic acid and also nitrate, make sure you have proper soil fertility, a proper amount of fertilizer, because improper balances can lead to your issues. One of them, if you have way more nitrogen and not enough phosphorus or potash, you'll increase chances of nitrate and definitely increase prussic acid issues. And to reduce that, you know, if you're worried about the low P in potash, do split application of your nitrogen. That's another way to kind of reduce the amount of prussic acid and nitrates. And for more information on that, go visit with a special soil scientist and a fertility specialist. I already told you, once again, this is great news. The process of haying or ensiling will completely remove all issues with prussic acid. That damaging of that epidermal layer, you know, I told you with mastication that some of the enzymes in the cattle cause the conversion into cyanide. Well, this diuryl that was on that first slide, it's in a different cell than the enzymes that break up into cyanide. So when you cut the hay and crimp it, etc., you break all those cells up, they get mixed together, and in turn, you produce cyanide. And that hydrocyanic acid, it evaporates. So you cut your plant, you cure it, it evaporates, it goes away. Now, still make sure you give yourself several days. I lean a little more on the ultra-conservative side, so I say about 10 days after cutting, allow about 10 days of curing before you feed that high prussic acid hay, before you cause issues. Because I really, really don't want to get a phone call from somebody saying, hey, you said at 5 days I could feed this and I killed 20% of my cows. That's not profitable for any of us. So I like the 10 days. If you can't remember the 10 days, a week should be a good value as well. What are other periods when prussic acid becomes an issue? Drought. Anything that restricts growth of the plant can lead to increases in amount of prussic acid. Actually, that drought-breaking rain, you think, oh man, that's manna from heaven, that's wonderful. That actually, if you are grazing those high prussic acid plants right after a drought-breaking rain, you can kill a bunch of cattle. You need to allow yourself a minimum of 4 days after a drought-breaking rain before you go out and graze those. Because those plants are wanting rain so bad. When they get it, they grow to growing so rapidly that the prussic acid levels are increased. Immature plants, because they are quickly growing, they have a lot of prussic acid. Your sprouts, regrowth, they're also high in prussic acid. Immediately after a killing freeze, you'll have high prussic acid levels. You've damaged the cells. You let the enzymes get with the cyanide. Any severe damage, hail. Right after a hail, you could have high prussic acid. Accidental herbicide or herbicide drift that kills some plants. Immediately after that, you could have high prussic acid in these prussic acid susceptible plants. Okay, so how many of you are like, we gotta get her gone. This is all doom and gloom. Well, if you know the bad times, you can stay away from them. So the secondary part, susceptible plants. You probably all know about your sorghum, millets, Johnson grass, Sudan grasses. And I had to throw in some ones that I figured you might not have known about. Horse nettle. Horse nettle out in your pasture potentially could be a source of prussic acid. Common milkweed can be a source of prussic acid. Many of your stone fruits, and especially wild cherry, that is a source of prussic acid. I'm not quite as familiar with geography. Do you guys have a lot of wild cherry, wild blackberry? Those, when those leaves go to wilting, that could be a source of prussic acid potential in your pastures. Black nightshade. When you actually go and count every single plant species in the world that can accumulate high prussic acid, there are 200 plants in the world that can have high prussic acid. Luckily, we only deal with a few of them on a regular basis. Now, I always get questioned about our pearl millet, foxtail millet, and corn. Do I have to worry about prussic acid with them? You don't. So if you're wanting to stay away from prussic acid issues, put those up or graze those. Well, actually, don't necessarily put them up, because every time you put up a hay, cut a high prussic acid susceptible plant for hay, what happens to the prussic acid? It goes away. You put up prussic acid hay, it all goes away. So what about if you want to graze? What are some management plans for grazing? Well, it depends on which annual forage you're interested in. We have rules of thumbs for different categories. So for your sorghums or Johnson grass, first thing, you need it to be at least 2 foot tall, 24 inches tall. At that point, usually your prussic acid levels are fairly low. And rotational or strip grazing is the best option. You want to, if you're going to rotationally graze, you need to leave 8 inches of regrowth, or 8 inches at the base to allow regrowth. And you want to make sure you consume that entire paddock within about 10 days. If you go longer than that, you have enough regrowth and reshoots coming up that you have high prussic acid. And the cattle selectively will choose those new green areas. Now, in contrast to nitrates, where most of the nitrates are accumulated in the stalk, prussic acid is primarily concentrated in the leaves. So the more digestible, palatable component that your cattle are going after is what they want for prussic acid, is where your prussic acid resides. If you're going to do a rotational grazing when you're coming up with your paddock plan, it takes about 25 days to get back up to that 2 foot, if you have appropriate rain and environment. But how many times do we have appropriate rain and environment? Yeah, that was another joke. Come on, folks, wake up. Yeah, we rarely have those. But the other thing, if you're going to do some rotational grazing with your sorghum, sedans, or even your millets, I recommend planting half of the acreage on the day you want and waiting at least 10 days to plant the other half. Otherwise, you're going to, by the time you get rotated to those back 4 paddocks or back 2 paddocks or however many paddocks you have, your plants are going to be so mature, seeded out, the quality is going to be junk. So give yourself 2 different planting dates. So what about sedan grass, sorghum sedan hybrids, and millets? Or the millets that have prussic acid, which does not include pearl millet or foxtail millet. These you can get out there when they're about 18 inches tall. They don't have to be near as tall as your sorghums or your Johnson grass. Once again, make sure you leave 8 inches. Still want to be out within 10 days. That's the maximum. If you wanted to do a quicker rotation, you could set it up on a week, every day, 3 days, however you set up your grazing management plan. And it only takes about 21 days to get back up from that 8 inches to that 18 inches. Okay, I think I put this several times. This is important again. If you're putting it up as hay or silage, after you allow appropriate amount of ensiling time, curing time, prussic acid is no longer an issue. What about after a freeze? Once again, I lean towards a little more conservative value. Wait at least 10 days after a good kill and freeze before you get out on these high prussic acid susceptible plants. Allows the cyanide time to evaporate. And I also threw in there, if you're harvesting milo for grain and you want to go and graze those milo stalks, you could have high prussic acid in those milo stalks after a freeze. So don't forget about those. Give yourself at least 10 days then too. After hay harvest, that regrowth, wonderful feed, wonderful feed. But once again, make sure you practice all these other rules I'd said. Needs to be at least 24 inches tall before you graze if it's a sorghum, 18 if it's a millet, and if it has been killed by a freeze, wait at least 10 days. Feel like a broken record, which is probably a good thing. Drought-breaking rain. They immediately grow. Wait to graze until you've either met the height rule. I like a week because that's an easy number to remember on after a drought-breaking rain. If you graze within 4 days after a drought-breaking rain, you will kill cattle. Missouri experienced that last summer. I talked to about 4 different producers there who each one of them killed 10 cows. Not a good event, not a good event. Okay, so in regards to prussic acid, here's a few summary points. It's very concerning from the fact that it kills so rapidly. But luckily, when you look at nationwide deaths due to prussic acid, it's pretty low. So we are doing a good job about managing for prussic acid issues. Management reduces risk of toxicity. Planning, planning, planning. That is the key to success with high prussic acid susceptible plants. You have to have a plan. You can't just turn out and think everything's going to be gravy. Haying and ensiling, safest way to feed prussic acid susceptible plants. So thank you for your time. Does anybody have any questions? I know this was kind of a dry, dull topic, but. So ideally you want to test on site. because it does evaporate so quickly. If you do want to send off your samples, you do have to practice special testing techniques. You need to grab at least 1 pound to 2 pounds of green forage around the whole field, immediately stuff them in a Ziploc bag or some kind of airtight bag, and put them on ice instantly and freeze them instantly. Get them to your testing facility overnight on ice, and tell them right off the bat they're testing for prussic acid. Because if they go to dry the sample, you'll have false negatives because all that prussic acid will evaporate and it will be a negative result. I haven't done the field test, the cyano testma paper. I haven't used it. Have you guys? Is it pretty effective? It's like it's a quantitative test, so it just says yes or no, prussic acid is here. But it doesn't tell you it's at this level that potentially could kill your cattle. Yes, it will. It will dissipate faster if it is conditioned or crimped, but any hay will eventually lose all prussic acid. Oh, and I guess the other quick thing, I forgot to put them in here, and I'll bring some more at lunchtime, but I have a handbook, potentially toxic forage crops or annual forages, and Oklahoma State and K-State, we have a mobile app, both iPhone and Android, to potentially toxic crops. So if you're out in the field, you can look up pearl millet, and you can see all the ways you could potentially kill cattle with pearl millet. So we have those links. So every other millet that is not foxtail millet nor pearl millet potentially could have prussic acid. So pearl millet and foxtail millet are the only two non-prussic acid. And there are varying degrees amount of prussic acid. Grain sorghums are the highest. Sudan grass is the lowest.
Where does teff grass fit?
Teff grass does not have prussic acid.